to the Emily STEM-ILY channel, where we love all things STEM, hence the name. If you're new here, my name is Emily and I'm a final year Biomedical Engineering and Medical Science student here at the University of Sydney. I'm really excited to be sharing with you today this video about biomedical engineering. Now, this is a field I'm really excited about, and I believe it's going to revolutionize the world in the next 10 to 100 years. But don't just take my word for it. I'm sure I'm a bit biased studying it myself. So I've got a quote for you here from Steve Jobs. You may know him from Apple. And he said, "I think the biggest innovations of the 21st century will be at the intersection of biology and technology. A new era is beginning." Now, I'm a really strong believer of this quote. Biomedical engineering is a really large part of that intersection between biology and technology. It's where technological advances are being applied to healthcare, and it's already made leaps and bounds in improving our human health, our quality of life, and even saving lives. So, what exactly is biomedical engineering? While most people may believe biomedical engineering is just a small subset of engineering, it's actually an incredibly broad field. The best way that I can describe biomedical engineering is any technology, innovation, or tool used in relation to human health. Now, this does include devices that you might be familiar with, such as the cochlear implant, heart pacemaker, hip replacement, knee replacement, or vascular stents, but it also includes so much more. Today, I hope to be giving you a really strong grasp of what biomedical engineering is and the huge breadth of it by giving a wide variety of all the different types of examples of devices that biomedical engineers make. First up, orthopedics. Orthopedics is the branch within medicine that focuses on injuries or disease within your musculoskeletal system. This system includes your bones, joints, ligaments, muscles, and nerves, and these structures are essential to how we move in our everyday life. Orthopedic conditions may result in pain or affect the functioning of the anatomical structure. So here, biomedical engineers and orthopedic surgeons work hand in hand to create solutions to help both reduce pain and restore function to the body. Did you know that the main reason for a joint replacement is pain? In orthopedics, biomedical engineers not only create devices that are implanted into the body, but they may also work on any tool or device involved in the surgery. To demonstrate this point, let's take a look at the example of spinal surgery. Spinal surgery may be a recommended treatment for certain cases of spinal trauma, such as fractures, spinal tumors, spinal deformity, and spinal infections. It may also be suitable in some cases for degenerative spine conditions, such as herniated discs. In these cases, an implant may be used to treat the deformity, create space for the spinal cord, or provide the optimum amount of stability and strength back to the spine. Did you know that with orthopedic implants, contrary to what you may think at first, you don't actually want a device that has the strongest possible load-bearing capabilities we can make, nor do you want it to be entirely stable. Think about it. As we move, jump, run, we not only need strength and stability, but we also need a certain amount of flexibility and elasticity as we compress, stretch, or twist our bodies. Additionally, there is a really fascinating process that happens within our skeletal system called bone remodeling. This is where old or damaged bone is resolved back into the body and brand new bone is deposited onto the bone. Yes, that's right. Your bones continually change throughout your lifetime. Now, there is something called Wolff's Law, which states that bones remodel in accordance with the amount of mechanical loading placed on the bone. Put simply, this means if more force is placed on a bone, it will become thicker and stronger over time, and if there is less force, it will become weaker. So let's say we made a hip implant made out of the strongest possible material we could make. What would happen is the body would adapt to place more of the force on the very strong implant, while we place less of the force on the surrounding bone. With Wolff's law, this would make the surrounding bone weaker. This means orthopedic implants are carefully designed in their structure and choice of material to distribute the forces accordingly. Examples of spine implants include pedicle screws and rods, plates, interbody cages, artificial discs, and growth-sparing devices. In a spinal surgery, biomedical engineers also play a role in the development of almost everything you can see in the operating theatre, from all of the many surgical tools used to advanced devices which are still in their infancy today, such as computer-assisted navigation systems, surgical robotics, and medical imaging, such as CT, MRI, and 3D imaging machines. There are now medical imaging systems that can provide real-time images to surgeons during the operation. Biomedical engineers are also working on developing VR simulations so that surgeons could virtually practice an operation before it even takes place. So in this video, we have discussed that biomedical engineering is all about the innovation of tools, devices, or technology used in relation to human health. We went on a deep dive into orthopedic and surgical innovations and used the example of spinal surgery to show many different types of devices and technologies developed even in just this one area. Next episode in this series, we're going to venture into the incredible world of tissue engineering. Make sure to hit the like and subscribe button to not miss this, and please share to anyone you know interested in this incredible field. Thanks, till next time.